All right, the next type of transformation that we are going to look at is called reflections. These ones might visually seem a little bit easier. Mathematically, it gets a little trickier as we do them, but they're the second type of transformation that are in our 7th grade standards. So that's what we're going to talk about today. Now, this one, like the other one that we just did, the translations, doesn't have a specific chapter section number like everything else you've done. So I've just called this reflections. It's in Schoology as since you found it. It's in the chapter 7 and 8, which is a lot of our geometry topics. And that's where you find it. So it's organized a little bit differently than all of the other materials we've been using. Okay, so here we go. Learning target for today. I can graph and find the coordinates of reflected figures. Okay, of reflected figures. Cool. All right, so there's your learning target today. I can graph reflections. I can find the coordinates of reflected figures. There we go. All right. Now, if I said to you, hey, let's think back when you were in elementary school and you had to all of a sudden maybe, like it was Valentine's Day and you had to cut out a heart, and you learned pretty quickly that it's really hard to try and even draw or cut out a heart that's perfect when you're doing it. They somehow, it just never seems to be perfectly symmetric. And so then someone comes along and say, hey, take this piece of paper and fold it in half like this. So it looks like this, kind of, sort of, okay? And on the fold, if you just draw half of the heart and then cut it out, when you take it out, it looks perfect because you've got this beautiful reflected image. Now, of course, I'm going to draw it by hand, so it's not going to look perfect, but there's a line of symmetry right down the middle. That's the fold line, and everything matches up perfectly on either side. Okay. So that's kind of the thought process that we're going to do today. So mathematically, what's a reflection? What are we talking about here? And so it's some sort of transformation. Okay. It's a change. And we start with, it could be a point. Most of the time, we're going to look at some sort of polygon, like a triangle or some sort of quadrilateral or some kind of shape. And basically, here's what happens. You flip it, in other words, reflect it across some sort of line of symmetry. Okay. And sometimes we call it the reflection line. Okay. This is your line of reflection. I guess that's the way it's most often stated. Line of reflection. There we go. Line of reflection. Okay. So this is what a reflection is. It's a flip. We're just going to flip flop things right over and they'll look exactly the same. So you have a notes sheet and we've got 6 examples, different scenarios there that I want you to look at. Okay. So here's the first one. Got this nice triangle GLQ here, and it says graph the image of this figure using the transformation given, and they want you to reflect it across the x-axis. Now, what I want you to do with your pencil, or if you have something that's a different color, that's even better. What I want you to do is when we find this line of reflection or that symmetry line, this is your fold line. So I want you to visualize what this is going to look like if we folded this across and where that point would land on the other side. So let's look at Q first. Q is right here. When we fold it directly up on top of itself like this Q is going to land directly on the other side of the x-axis, 1 unit away, still on this same vertical pattern or on the same vertical line here. Okay, so this is our new Q, and we have to call it Q prime because that's the transformed or the reflected image or point. G is up here, and when it gets folded down, it's going to show up down here precisely 1, 2, 3, 4 units away from the line. So 1, 2, 3, 4 units away. Again, it's on this same line because we're folding it exactly straight over like a sandwich or something. That's G prime. And L is right here, and when we fold it, L prime is going to end up right here, 2 units away from this reflection line. Now connect these dots. Boom, boom. Oh, I can't draw straight for the life of me here. Okay, there's your reflected image. And when you finally get it, then it kind of makes this cool design. When you look at it, everything's perfectly symmetric on the cross that line. All right, I'm going to do something a little bizarre now. I want you to jump to example number 4. Can you do that? Number 4 looks like this. Reflect across the x-axis again, okay? I want you to take and put it like a dotted line where that line of reflection or line of symmetry is going to be, because then you get the visual of folding it, and there you go. So let's start with this one. P is going to end up being reflected 1 unit away above the line. So this is my new P prime. D is up here 4 units above the line, so D prime is going to end up down here. Z is 3 units above, so now it's going to be 3 units below. Okay, this is a D, by the way. And last but not least, M. Weird. M is sitting smack dab on that line of symmetry, so guess what happens? Doesn't move. So this also becomes M prime, and we just layer that dot right on top. Now connect them. M prime to P prime, M prime to Z prime, P prime to D prime, Z prime, D prime. There you go. That's what it looks like. Okay, let's take a look at a couple others now. Because number 2 says reflection across y equals 3. Okay, hold your horses. I need a line. I'm giving you a line. It happens to be this line where y is always equal to 3. Now, you're asking yourself, well, how on earth do I know what that looks like? Here's how you can visualize what this is. On your y-axis, put a dot where the y is 3. Okay, there it is. Y-axis, y is 3 right there. That actually is the point 0, 3. Okay, now what the line y equals 3 looks like is, you know what? Give me any point you want, baby. The y value is always 3, and you can put whatever you want for x. I could have 1, 3. I could have 2, 3. 2, 3 is right there. You could have 3.5, 3 if you wanted to get fancy. There's 3.5, 3. Do you see where this line is? -1, 3. My y value is always 3. See what's happening? You get a dotted line. It's horizontal and happens to cross where my y value is 3. Visualize this as your fold line now. Okay, so here's what happens. X is 2 units above this fold line, and now X prime will be 2 units below. The U is going to end up being right here where actually my existing L is. So I kind of have to write the dot over it and put U prime right next to it. L gets reflected above, and L ends up being exactly where the original U was. So we reuse this line segment, but here's what looks different. And it folds over and looks like that. Okay? Let's try the other ones on here, just so you know. Reflection across the line y equals 1. Okay, this is a line. It includes all points where the y value is always 1. On the y-axis, where is 1? It's right there. And then you start filling in any other values you want as long as you keep the y value as 1. 1, 1, 1, 1. Aha! Okay, it's a horizontal line. This is your line of reflection or a line of symmetry. Okay, let's go to town on this one. Start with the point I, which is 1 below. So I prime, the reflected point, is going to be above. T is 3 units up, 1, 2, 3 units down. T prime. And here's y, 1 unit above the line. Now y prime is 1 unit below. Connect these, and you end up with your reflected triangle across the line y. Oof. Oh, across the line y equals 1. All right, we did number 4, cool beans. Now let's do this one. It just takes it one step further where it did not give you the image, you have to graph it. So T is at 2, 2. C is at 2, 5. Z is at 5, 4. And F is at 5, 0. Okay. So this looks like some kind of either a parallelogram or no, not quite, because there's a little difference here. So some kind of quadrilateral anyway. Okay, well, now it says reflected across the x-axis again. Okay, so here's my x-axis, the horizontal. Let's reflect it. And I'm going to switch colors just because it can, so it's a little easier. T is 2 units above, so T prime will be right there. C is 5 units above the line. C prime is 5 units below. Z, 1, 2, 3, 4, is 4 units above. 1, 2, 3, 4, 4 units below. F was already smack dab on the line of symmetry, so that stays. There we go. This one did say just go ahead and graph it. Okay, so there you go. Last but not least, do this one. H is at -1, -5. M is at -1, -4. B is at 1, -2. And C is at 3, -3. All right. Nice quadrilateral here. Okay, now this one says, please reflect this across the line y equals -2. Well, here, I gotta change color. Here is where y equals -2, right here. That is at that point, 0, -2. And then basically it can be anything else that's on the line as long as my y value is -2. So just grab any old value you want for x, whether it's 1, -2, 2, -2, -1, -2, and so on. And basically you have this horizontal line. This is the fold line. You need to reflect this across. So here's M prime. Right? Yes, 2 above. H prime should be directly above that. This is H prime. Okay, that's 3, 3. B is not going to move because it's directly on your line of symmetry or your line of reflection. And C prime will end up being up here. All right, so we get this, and this, and this. My drawing's not so great, so hopefully you'll have better luck. And feel free if you want to use a ruler to make your lines a little straighter. Your assignment for tomorrow now is to practice visualizing and drawing some of these reflections across given lines on your assignment. Okay, so grab your worksheet, go ahead and get started. And as always, may the force be with you.